Good morning and a warm welcome to our second day at the BAU Online. We are here in Hamburg, not in Munich, unfortunately, but we hope at latest in 2 years we are back there because we are missing a little bit the personal contact, and to talk to a camera, it's unusual to us. Okay, again, good morning. Maybe some of you have followed our live seminars yesterday, and we do it exactly the same way. Questions at the end of the session. Stefan again is here, my colleague, who will follow the chat and give us the questions. So, you already have seen our company presentation. A few words about WEBAC, who we are. Maurice, we forgot to introduce ourselves.
Yes.
Now I see it. My name is Markus. I'm in charge of the export department. And Maurice?
Yes, my name is Maurice. I'm also working in the export department and I'm responsible for application engineering, site support and sales in general. And now Markus is going to tell you something a little bit more about our company, so I just pass it on.
Right, thanks. WEBAC was founded 1978. We are still a medium-sized family-run company. We are located here in Basbüttel with our production, with our research and development center. This is very important. As you know, you find different climate zones, so their short way into the laboratory is essential for us. We are here in our seminar room, which becomes suddenly a TV studio. Normally we give here and this place trainings for designers, where the focus is on durability of the building. We give trainings for applicators. This is a little bit more hands-on training, how to drill, how to inject, what is the right injection pressure. But also for site managers, how can I control the injection works? What is in focus? What kind of material has to be used? Yes, we also provide the service, a site service. So if you have questions or if you have a building site where you are a little bit unsure, what kind of material, how to apply, give us a call and we are at your site. Today, our live seminar is about the sealing and stabilization of concrete. Should it be force transmitting? Should it be simply waterproofing? There, Maurice will tell you, will go more into the details.
Yes, I do. So our seminar is scheduled once again for 30 to 35 minutes and it will contain the following topics. So we are going to talk about the principles of crack injection, the analysis, what kind of state of dampnesses are on your building, the objective of use, what kind of filling materials are there, what is the difference between them, and how does the injection procedure looks like. As you can see here, we are talking about cracks simply in concrete. The reasons for the cracks, why they occur, how they are treated, are going to follow now. First of all, we would like to talk about the standard. There is a European norm which regulates the crack injection in reinforced concrete. It is called EN 1504-5, and maybe you can see it here or highlighted here. The harmonized norm was harmonized back in 2004. So, and just to make sure what we are talking about, we have made a comparison from 2004 to 2021 with mobile phones. Probably all of you know how the standard in 2004 was and how it looks like today. And you can also apply that on the injection industry for sure. The development of the injection materials has been ongoing, and therefore there might be some products that are even better or that does not fit into the norm that has been harmonized almost 20 years ago. Like usually, I think most of you have followed our presentations yesterday. Once again, it's very important to carry out an analysis prior to your injection. So first of all, we would like to talk about the reasons why the cracks occur in concrete, and therefore there are two main reasons. One are related to the concrete properties. You can find them on the left-hand side, and the others are related to stress on the right-hand side. So first of all, you probably know how the concrete is behaving during the reaction. So there is height rotation in the concrete. The concrete can shrink, or there are creep pitches, or the concrete can even start to swell. So therefore, all these reasons that are related to the concrete properties, they can cause cracks in the concrete. The other ones are related to stress, and that can be loads, deformations, temperature impacts, or deformations of your soil. What does that mean? If your building, for example, was designed for loads with forklifters of 5 tons, and after some time you see that there is a change, that the forklifters are 10 tons or 15 tons. For sure, this is also going to have an influence on your structure, on your concrete. So therefore, unexpected loads on the concrete can cause cracks. Temperature impacts, difference between summer and winter times, big changes in temperatures, or deformations in soil, like you have washed out soil underneath your structure, you have settlements, and these settlements for sure can also cause cracks in your structure. It is very important to measure the crack widths prior to the injection, and there are two ways of doing it. You can simply measure with a crack scale the width of your concrete on the surface. The other option, which is not more complicated, but you have to do further works, is just to take out the core drilling. And this core drilling for sure gives you a better feeling and understanding how the crack is going in your structure. Is there any change in the crack width? Is it smaller, thinner? Is it wider? Is it an even crack in the concrete? Are there pathways? So these are things that you cannot see from the surface, and therefore you would need to have to take out the core drilling. Also, as you can imagine, there can be crack width changes, and depending on the changes, you need to see when the best time is to inject the crack. The most common or the most known area where you can see it is the bridge deck. So you have the expansion joints, and for sure, in summer times when it's warmer, the concrete is a little bit wider and the expansion joint is smaller than in winter times when the concrete is cold and it's like shrinking once again. So the expansion joint is always a good indication about also the crack width changes, and you have to be aware of that and keep these changes in mind when you carry out the injection. So, just to summarize what we just have been talking about, before you carry out the injection, you would need to know the cause of the crack. Why do I have a crack or cracks in my building? Then for sure the widths and the changes of the width, and also if there are further damages in your building. There is going to be an overview what kind or what things are going into the concrete repair work. So we are talking about construction joints in your basement. Depending on the concrete quality, there can also be gravel nests or just cracks. Once again, the connection bottom slab and wall, the construction joint there, or especially when we are talking about basements and you probably are below groundwater level, there you can have the influence of water. Or if you're above groundwater level, then you probably, or we are probably talking about dry cracks here.
Yeah. There the point is also, due to the shrinking of the concrete, you will receive mostly here in the wall separation cracks. And these separation cracks will go through your whole concrete, by meaning the reinforcement is also exposed to water. And this can cause also corrosion of the reinforcement. And for the lifetime of the building, this is a big case. So shrinkage, it is in the interest of the contractor that he pour the concrete, he don't use a lot of crack inducers. So these are the most common cracks which have to be treated. Let's talk a little bit about the state of dampness. You mentioned it already. There are different state of dampnesses above groundwater level, below groundwater level, and you have to treat them different. So, state of dampness, everybody knows what is a dry crack. Here in the crack you see no water penetration. The definition in the norm is a little bit funny for me. Water penetration is possible, but has not been the case for a long time. How can you measure this? Huh? I always, when I hear this sentence, I always think, an engineer sitting with a chair in front of the crack and observe it. But in my world, a dry crack is a dry crack. Then you find damp cracks. All of us have seen it, where you see here some shadows. In this case, cracks close to the surface. Here's a smaller one, but here you see also penetration of water along the reinforcement. Then wet cracks. Wet cracks, you see here. There you find water in a liquid state, and also here you see some finer drops coming out of the crack. So this is a definition of a wet crack. And last but not least, I don't hope that you have this case in your basement, pressurized water. So water is coming out of the crack, or in this case, out of a sheet pile wall in a liquid and pressurized state. 4 states of dampness: dry, damp, wet, and pressurized water. And these cases has to be analyzed, and according to this, we are choosing also the filling material. The filling material. The definition in the 1504/5 makes the difference between the performance and the workability. The performance is simply only this case, what would you like to achieve? Would you like to glue the concrete together again? By meaning this is a force transmitting filling category F for structural bonding. Then the ductile filling of the crack. You will come later to the point of the material. This material is a little bit more flexible and can take some movements. And last but not least, category S there we are talking about acrylic gels, mostly for the swelling fitted filling, by meaning the material is swelling a little bit, and due to the swelling pressure, the crack gets sealed. So on the workability side, you already mentioned it, it is important to know the crack width. You cannot inject a crack with 0.001 millimeter. That's simply not possible, but it will be dry anyway, so it's no need to. You have to take in consideration the minimum and maximum temperature, and also the crack width change in or during the injection. Okay, Maurice, now it's your turn with a
comparison of the impregnation and injection. So usually there are two ways how to seal cracks in concrete. First of all, we are talking about the impregnation, and as you can see, the impregnation is something that is going into the structure by gravity. So you just pour in the injection material into the crack, or you brush it in. As you can see, for sure, the filling grade is not that good, and therefore it's only a surface leaf filling. In comparison to that, there is the injection, by meaning we are working with drilling and placing packers, using high pressure injection pumps, and therefore, for sure, the filling grade inside the structure, inside the crack of your concrete is higher, and this is usually the target of injection, that you achieve a high up to a complete filling of the crack. But for sure, in some cases, the impregnation might be enough for the case, and therefore now there is going to follow an application video which shows you the steps of the impregnation. So as you can see, first of all, for sure, you have to make sure that the crack is wide enough. So you use a grinder just to widen the crack, and afterwards you suck off the drill dust out of the crack so that the injection resin is able to penetrate into it. Now we are going to show you the mixing. Most of our products are two-component based, so you have to mix both components prior to application. Mixing ratio can differ, and therefore you need to make sure that you mix the product in the right ratio. As you can see here, the guys are using an epoxy resin there. It's very important to make a repotting of the injection material, because you need to achieve a very good mixture of the material. This is happening now. Now they are refilling it into a smaller measuring cup that makes it easier to fill it into the crack, and they are going to fill it up now. As you can see, the material is going into the structure by gravity. The colleague is pouring in the material and it just sinks down. This step has to be done a couple of times, because for sure the injection material is going to penetrate into the concrete, find fissures, cavities and so on. So material is gone and you have to repeat the step of filling until the crack is filled up to the surface. Once you achieve the filling grade to the surface, you can just apply some quartz sand to smoothen the surface. And after curing, which is going to follow in a couple of times, so the material needs some time for reaction, and after it's cured, you just brush off the quartz sand, and afterwards you can grind the surface again to make it smooth, and afterwards you can start to apply, for example, a coating system. So that was the crack impregnation, and I would now like to hand over to Markus, who's going to talk about the injection and how to do it.
Perfect. Thank you, Maurice. In comparison to the impregnation, we find the pressurized injection with drill hole packers. So you find in the standard and norms, or we often get the question, what should be the distance between the packers? So the distance between the packers, it should be the half, roughly the half of the construction thickness. We should always inject from the lower part to the upper part. That's very important. And we should drill into the concrete of with an angle of 45 degrees. I hope you can see this picture here. The reason is that if you are standing in front of the crack, you will never know how this crack went in the construction. In this case, it goes to the right side. And with this angle of 45 degrees, you ensure that you intersect the crack. That is the reason for the angle of 45 degrees. So, distance, in general, you can say half of the construction thickness. If you now have a slab which is 1.80 meters, you will probably not drill 90 centimeters into the concrete, but this has to be seen case by case. Always a question, and there in Europe opinions are totally, or worldwide, the opinion is different. For example, in the north of Europe, they are simply saying, okay, I inject with a lot of pressure because then the material get a better flow and I widen the construction joints a little bit so material can flow in better. We say, and this comes simply out of our experience, lower injection pressure over a long injection time give the best results. A rule of thumb is to reduce the maximum pressure like following: the cube concrete strength divided by 3 times 10 bars. So for C20, 25, it should be not more than 80 bars. And 80 bars are 80-meter water column. In my world, that's a lot. Again, this is general speaking. It depends on the case and on the building site. So how this works now, I would like to, we have prepared a small video and let's take a look at this. So here we see a wet crack, I would say. Drops are coming out of the crack. First of all, you mark your drill holes in the distance we discussed. Then you are drilling, you can see it here very good in this angle, to hit the middle of the construction. Very important to remove the drill dust, because that's quite easy to understand. If you are pressing the drill dust with the injection material into the crack, then you block it and the injection process will not be so easy. Afterwards, you are installing the packers and patch the crack, simply to prevent that material which you are injecting in the packer is coming out immediately to the inside of the building. You would like to push the material. We have seen it in the earlier graphics. You would like to push the material to the outside of the building. Very important, at the top of the crack, leave a venting opening. In this case, we are using polyurethane injection resin for the ductile filling of the crack, so it can take some movements. material is mixed, filled into the pump. So, and then the injection process starts. Again, always from the lower part to the upper part, and you have seen it at the video. Sometimes water which is in the crack is coming out of the next packer, and this is you are injecting for a longer time, and if you have filled then the complete crack, you see the material is coming out at the top. Very important is a secondary injection, because due to the gravity, the material gets sucked into finest fissures, and if you are injecting from the bottom to the top, this re-injection is essential. Removing the patching, and make the surface nice and even again. Okay. Summarize. During the injection, it is very important to observe the pressure range. Always injection from bottom to top. Don't forget the venting opening, and a secondary injection within the pod life is essential for good work. And then dismount the packers, close the drill holes, and you are done. You are ready. So, Maurice, I would like to hand over to you. You can tell us something about the different kind of material classes.
Yes. So last but not least, before we coming to your questions, we will now have a short overview about different kind of injection materials and what they are used for. So we are now going to start with our PU injection foams. As you can see, I just let the video run. In the meantime, you can see that our employee has started to mix a product. So the PU foams are water reactive. They will not work in a dry surface. They are only designed to stop very high water income. Coming back to the state of dampness, this would be the option for the pressurized water. So they are water reactive, very fast reacting. They are start after some seconds, highly expanding. Due to these properties, the high expansion, there is a lot of CO2 inside the foam structure, by meaning you have like small bubbles within the foam structure. In this foam structure, there might be the possibility that there is a water penetration possible after a certain time. So therefore, it is only a temporary sealing, by meaning you would have to carry out another injection with another material type to make it a long-lasting sealing. Maybe you have seen it in the meantime. It was a small amount of material, just some drops of water, and the expansion is up to 40 times. So it's very fast reacting, highly expanding. And as you can see, you have an even foam structure here. Now, coming to the next injection material, we are talking about the PU injection resins. They are designed for the ductile filling of cracks, and they can be used in dry, damp, and wet cracks. So they are very flexible, by meaning they are designed for the ductile filling of cracks. Also water reactive, so if they are getting in contact with water, like you can see in the video, this material also starts to foam. But as you can see, we just put it on a time lapse. It's not seconds, we are talking about a certain time of minutes. Depending on the material, it can be between 10 to 30, 40 minutes. This material and also the foam structure is designed for a permanent sealing because they have a watertight pore structure. So if you would put the foam underneath the microscope, you can see that the bubbles, or there are not too many bubbles, and you have a watertight structure. So if you're injecting a PU resin like this, the crack is filled and you have a long-lasting sealing. As mentioned before, regardless of the degree of moisture, so it's dry, damp or wet, and for sure you can adjust the reaction time by using accelerators. Especially now in winter times, there might be the need to speed up the reaction. The epoxy injection resins, they are designed, or they have a high compressive strength, a high bending and tensile strength. They are tough and solid, and they have a very good adhesion to concrete edges. So therefore, due to the high mechanical properties, these materials, the epoxy injection resins, are designed for the force transmitting filling, by meaning you glue the broken concrete parts together and give back the strength. The mechanical properties, the compressive strength of these materials are higher than the standard concrete. So we are talking about a strength of 40 Newton per square millimeter or even higher. And finally, the swellable fitted fillings are the acrylic gels. As you can see in the video, they have a very, very low viscosity, by meaning it's more or less comparable to water. They also have a very good adhesion to dry, damp and wet substrates, and the reaction time can easily be adjusted by the amount of component B of the initiator of that product. As you can see in the video, they have a very high elasticity and a very good adhesion to the concrete. So if you would have a case like that, that your building is having movements like that, just get out of the building and run away.
Then you don't have any problems with the waterproofing, so there you have bigger problems. Okay, Maurice, thanks a lot. If you have questions, don't hesitate to contact us, and I can see here in the chat there are already some questions, like yesterday. Stefan?
Yes, Markus.
you
Thank you guys
read
again
it?
for this great presentation. Markus, I have right now the question coming to your side about the secondary injection. So this is a question, what is the purpose behind, and maybe you can explain, should it be done the next day or a week later, or what is the background behind it?
Okay. How can I explain it better? The situation is, let's say this is a crack. Here is a crack. You are standing in front of the crack. You have drilled from both sides. You injected to the top. So then you go with a secondary injection. Material is now, due to gravity, going into the structure, into the concrete. So, and if you carry out then a secondary injection, start at the lowest point within the pod life, and you see immediately material is coming out at the top or at the venting opening, then you have done a good job. Most of injections are failing because the guys didn't carry out a secondary injection.
Markus, for that explanation. So I have another question for Maurice. He can answer that. So there's a question about the patching. So is it, we saw it in the video, but is it necessary? What is the purpose behind that? And it depends on the material type, or what do you say about this?
Yes. So a patching is not always required. For example, as we have seen in the video, we were talking about a wet crack, and usually, or in most cases, wet cracks are just injected without a patching. A patching is of course necessary when you work above your head, overhead. So just to prevent that the material is coming out immediately out of the crack, you patch the crack prior to injection. Another case where we always recommend to use the patching is for a force transmitting filling if we are working with epoxies, because there it's very important to achieve a high filling rate. And according to the standard here in Europe, you need to achieve a filling rate of at least 95% to have a successful injection, and therefore just to prevent that the material is coming out too easily or that the material stays inside your construction, for a force transmitting filling, we always recommend to use the patching.
Thank you, Maurice. So there are another questions coming up here, but maybe they are too deep into the theme, so we have to use the opportunity to answer that per mail.
That was easy.
Yeah.
Thank you. Okay, then here the timetable for the next live seminars. We will have at 11 Rissinjektion, correct injection as a German-speaking online seminar. At 3 o'clock, curtain injection, Schleierinjektion, and tomorrow we guide you into bigger building sites in the tunneling, mining business, and stabilization of ground.
Yes. If there are further questions that you would like to discuss with us face-to-face, there's a possibility to book a one-to-one meeting during the BAU online, or as mentioned by Markus earlier, you can always call us or send us an email. So please feel free to get in touch with us.
Super, thank you, and we hope to see you latest in 2 years face-to-face in Munich. Thanks you.
Thank you for your attention.